So laboratory techniques and measurement is the first of the actual lab experiments that you're going to have to do. And when we look at the drop-down menu, we see there are three sections, which you'll always have for each lab. The exploration, which is the background, and then the exercise part, which is the actual activity, and then the evaluation, which is where you have the questions and the data tables, which you will be filling out along the way. So let's look at exploration. For this experiment, it says exploration will take about 30 minutes. It may take a little bit longer. What you're expected to do is read through each of the different pages, and most of this will be review. If we look at this first page looking at the International System of Units, we know that the International System of Units is the standards, and the metric system is based on that. And we will use the metric system in lab throughout the semester. And here are some common laboratory units: centimeters, grams, seconds, Celsius, and a millimole is a thousandth of a mole, and a milliliter. There are also some conversion factors here between imperial and metric system, as well as the meaning of the metric prefixes. So these are all references that you can use and are a review from Chapter 1. And then it goes into some detail about the different physical properties: length, temperature and time, volume, what that means. And then one thing I want to point out here: when you are measuring the volume of a liquid, you always measure the volume according to where the bottom of the meniscus is, not the top, the bottom. And in a glass cylinder, an aqueous solution or water will always be curved in this concave form. So you'll always measure it from the bottom of the meniscus. So it gives you some information about the volumetric flask as well as a graduated pipette, some important measuring devices in lab. Important to read because it tells you what the markings mean. How to determine the volume of regularly and irregularly shaped objects. And then Archimedes' method, we determine the volume through displacement, and that can be a little tricky. Sometimes the density we get is not what we get from a different approach, so that can be a little bit tricky. Then there's some more information about mass and the definition of density. And here, concentration, we have not gone over this in class, so let's just talk about this right quickly. Concentration is just how much of something that's dissolved is in the solution. So here we're looking at percent mass of what we're dissolving, which I believe is salt in this experiment, over the volume. And so this is just a measure of concentration. There are lots of different ways we can measure concentration, but that's what we're going to do today. So mass per volume. So we calculate that by taking the grams of the solute, which is what we dissolve, over the milliliters of solution, which is what we have when we add the salt to the water. That will be our solution. And then we multiply it by 100 to get our percentage. So that's going to be our concentration. Now this equation right here, C1 times V1 equals C2 times V2, that's the equation we're going to use because we're going to dilute a solution. So C1, or concentration 1, is the concentration of the concentrated solution. And then V1 is how much, the volume of that concentrated solution we measure out. Then we add water to it to get a new volume, that's V2, and our new concentration, C2, will be less than C1 because we've just added water. So C1 is concentrated, V1 is the small amount of volume we take of that concentrated, V2 is our volume after we add the water to it, and C2 is our new concentration. So there are 4 variables here, and you will know what C1 is, you will know what V1 is because you'll be measuring it, you'll calculate C1, and you'll know what V2 is because that's the final volume after you add the water. So you'll generally be solving for C2, and this is just an algebraic linear equation where we have 4 variables, and you'll be given 3 values of those variables and solving for 1 unknown. So right here is a little bit of an example. Here you're solving for V1. So we haven't gone over concentration too much in class. We really haven't gone over it all yet, but we will. And as long as you know that C1 is your concentrated concentration, and C2 is your diluted concentration, and V1 is the volume of that concentrated solution, V2 is your new volume of the dilute solution, you should be good. And if you have any question about what is what, I'm happy to answer that by email. And then we have percent error. So percent error is basically a measure of how good your measuring is. And so we have a measured value, and you subtract the accepted value, which has to be given to you, divided by the accepted value, multiplied by 100. So the measured value minus the accepted value, we take the absolute value of that, so we don't have a negative, and just multiply by 100. All right, so here we want to look at the materials. You want to make sure that you have everything that you're supposed to have. And then here are also what the HOL kit will supply. Make sure you have those out and available.